Yo, yo, yo. Okay. Hopefully you guys can hear me, right? Hello, hello. Am I audible? Hello, can you hear me now? Is it better? Any better? Okay, cool. Sorry, I have a whole new system set up. Like just for next 2 weeks, I created like a whole system on Mac in last 2 days. So I could work, I could get things done. So apologies with all the things going on. Like even if you see this, right? Like it's such a bad like screen. Like I don't know what to say. And this ad, I don't know why there is another ad going on. Hopefully it stops. I'm trying not to put ads at least for next 2 weeks as I'm going on creating a AI influencer with all the things, right? Um, and live on YouTube as well. So hopefully that goes sounds good, right? I think I just want to make sure on YouTube I'm there. But yeah, so today we'll be actually diving a bit more into some how to say a bit more mathematical stuff. Yes. Yes, please. Let me know if my audio goes off or anything like that. Please let me know. Sir, is it too loud right now? Is it super loud? Because I can reduce the loudness and stuff. I can manage from here, like with this. Okay, sounds good. Awesome. Thank you. So yeah, with that being said, let's move to our AI stuff where we were going through Udacity, right, by Accenture. And we completed certain dimensions regarding, let's say, if we are have grades and test results of a student, whether the person should be accepted to the college or not, right? Yeah, yeah, no, 100%. Thank you. There is that. That is the reason, probably. No, I'm in my friend's house, as I mentioned yesterday, so that's good. Thank you. But yeah, today mostly this will be learning. I will be hardly saying much. I'm just going through the mathematical stuff, so probably not a lot of people will like it. Probably it's not like everybody's cup of tea. Um, but with this, once this is done, we will have neural networks, how things work, how our human brain works, and how AI is mimicking that stuff, right? So let's get
So
into that.
let's recap. We have our data, which is all these students. The blue ones have been accepted, and the red ones have been rejected. And we have our model, which consists of the equation 2 times test plus grades minus 18, which gives rise to this boundary line, which is the points where the score is 0, and a prediction. The prediction says that the student gets accepted if the score is positive or 0, and rejected if the score is negative. So now we'll introduce.
You guys can hear me though, right? My video got paused on my Twitch app, trustingly. Okay, yeah, you
Introduce
can
the
hear me.
notion of a perceptron, which is the building block of neural networks, and it's just an encoding of our equation into the
Sorry.
score is positive or 0, and rejected if the score is negative. So now we'll introduce the notion of a perceptron, which is the building block of neural networks, and it's just an encoding of our equation into a small graph. The way we build it is the following. Here we have our data and our boundary line, and we fit it inside a node. And now we add small nodes for the inputs, which in this case, they are the test and the grades. Here we can see an example where test equals 7 and grades equals 6. And what the perceptron does is it plots the point 76 and checks if the point is in the positive or negative area. If the point is in the positive area, then it returns a yes. And if it is in the negative area, it returns a no. So let's recall that our equation is score equals 2 times test plus 1 times grade minus 18. And that our prediction consists of accepting the student if the score is positive or 0 and rejecting them if the score is negative.
So this is like a think about it as like a black box or anything like a function. You put like two variables inside it, it calculates their value, and based on whatever the value comes out, you are making a decision if this or this, right? If score is greater than zero or equal to or greater than zero, student accepted, else false.
These weights, 2, 1, and minus 18, are what define the linear equation, and so we'll use them as labels in the graph. The 2 and the 1 will label the edges coming from x1 and x2 respectively, and the bias unit minus 18 will label the node. Thus, when we see a node with these labels, we can think of the linear equation they generate. Another
Wait, hold up. So
bias
basically, these two and one you see here, right, on the arrows, that's called weight of those variables. So twice the weight of this one and once the weight of this one into the function.
unit minus 18 will label the node. Thus, when we see a node with these labels, we can think of the linear equation they generate. Another way to graph this node is to consider the bias as part of the input. Now, since W1 gets multiplied by x1 and W2 by x2, it's natural to think that B gets multiplied
And the last a minus 18 is called the bias.
by a 1. So we'll have the B labeling an edge coming from a 1. Then what the node does is it multiplies the values coming from the incoming nodes by the values on the corresponding edges. Then it adds them, and finally it checks if the result is greater than or equal to 0. If it is, then the node returns a yes or a value of 1. And if it isn't, then the node returns a no or a value of 0. We'll be using both notations throughout this class, although the second one will be used more often. In the general case, this is how the node
Give me 1 second, lads. I'll get some water. Give me 1 second. Apologies, apologies, apologies. 1 second. Okay, I'm back. This is better.
nodes look. We will have our node over here, then n inputs coming in with values x1 up to xn and 1, and edges with weights w1 up to wn and b, corresponding to the bias unit. And then the node calculates the linear equation wx plus b, which is the summation from I equals 1 to n of wixi plus b.
Mhm.
This node then checks if the value is 0 or bigger, and if it is,
So this symbol, the E type symbol is called sigma, basically saying W1 X1 plus W2 X2 plus W3 X3 plus it goes on till Wn Xn because there are n dimension, n variables, which becomes Wx basically altogether.
is, then the node returns a value of 1 for yes, and if not, then it returns a value of 0 for no. Note that we're using an implicit function here, which is called a step function. What the step function does is it returns a 1 if the input is positive or 0, and a 0 if the input is negative. So in reality, these perceptrons can be seen as a combination of nodes, where the first node calculates a linear equation on the inputs on the weights, and the second node applies the step function to the result. These can be graphed as follows. The summation sign represents the linear function in the first node, and the drawing represents the step function in the second node.
So first is calculating the values, second is like the if-else conditions.
In the future, we'll use different step functions, so
Okay.
this is why it's useful to specify it in the node. So as we've seen, there are two ways to represent percent
Wait,
function
hold
in
on.
the second node. In the future, we'll use different step functions, so this is why it's useful to specify it in the node. So as we've seen, there are two ways to represent perceptrons. The one in the left has the bias unit coming from an input node with a value of 1, and the one in the right has the bias inside the node.
No more hack string. Yeah, thank you, Bandit. Actually, the thing is, I'm not at my home because of some personal reasons. I have to come out. I'm in a whole different city. So I will be back home on 26th. 27th, we are doing over the wire, like on Sunday, a whole big stream just to catch up and as apologies to everyone. But right now, I thought, like, this is a good time to learn some AI, get into some nitty-gritty AI related mathematics and just staying connecting with people because so many people have subscribed, right? So, and so many subscriptions are there. So, yeah, yeah, out of town area. Yeah. And I thought like I will be probably getting somebody. So I wanted to talk to you actually if you would be interested next week to chat about like what you did with Metasploit and stuff. And also I'm talking to Campy. Next week he created a Linux distro, which is from Debian. Yeah, if you're down, you can just have your voice like through Discord, and I can just point that. I just will have questions bunch of questions. You can talk about your story and how people who want to, get into like open source contribute to Metasploit. Yeah, 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 that's fine. 100%. Like just Discord will be good enough. Like we can just do talk however you like. Will be nice. Because I think it will be nice. Like so many people. What I feel right is that when I was in university, we don't get like proper education on, let's say, how to contribute to open source, how to be part of a community, how to like give back to community, which a lot of students I think want to do because it puts them on a good path. So because of your help, right, I will be able to like bring those questions up, demonstrate certain things, and help students. Because as a student, I never got that help, so I want to provide that help, and I think you would help. Your help will be very big part of it if you're down, and I can send you the questions I will be asking and would be like around 1 hour or 1.5 hour type of interview if you're down. But yeah, that's how AI and doing all the things I want to do other than hacking during this time. That's the whole goal, I will say. Sure, sounds good. I will contact you in Discord and we can set up some timing and we'll do some good stuff. That'll be great. Thank you so much. Thank you. It'll be great. I can't wait to have that because I want to. One of the things I want to do with streaming, because streaming is like one of my ways I feel like I can get out of the 9 to 5 job where I'm just making other millionaires, billionaires, more billions of money. With this streaming, I can just help people find a job for some time or do things which they were interested in, like open source contribution. That's a fun one, right? AI, just hacking games, like, and just talking to people and like creating a community. Oh, it's 3 a.m. here for your side. Yeah. How much time? What time is it? Yeah, it's 11:50 for me. It's interesting. Yeah. Like we are hackers. There is this saying from a very old Indian Hindu show, which it says like, why all the demons operate at night, right? And the guy says, because at night time the demon power goes 10x. And I'm like, and that's what like the meme is like, why hackers like to hack at night? Because the hacker power, the demon power goes 10x. It's the same idea. Like I'm up since 8 a.m., but I'm just every time this clock hits around 10, 11, and streaming time comes, I'm just super energetic. I'm like, I want to do more. It's so fun. The nighttime, like I think I'm an owl. Like I tried and I was at one point. Yeah, Super Saiyan mode. Oh, it's funny actually. I'll show you something. Can you go? I'll show you something actually. Twitch. Oh, here. So if you go on my Twitch here, and if you see my screen, there should be like a. I want to see. One sec. Hackers Pub. There is a Super Saiyan one I have. Hackers Pub. There is a super. Okay. If you go on these stickers, right? If you check, uh, open extension on here, like remove this. There's Super Saiyan here. Uh, One sec. Oh, I don't have it right now with my this one. Oh yeah, I have to set it up. But there is one Super Saiyan one here, which is amazing. Once I'm back in my um like home, I have everything set up there better, then that should be available. Right now I don't have it. Yeah. I have those. And I made like every single bits one which I could. I think I turned like majority of them 0 bits so people they can just have fun, right? They don't have to pay to have fun. That's the biggest reason of my community. Like I saw this indie game developers tweet, which was about a community is shouldn't only uh, be for people who can afford it, and that's like my goal too. Like I was like, I want to build a community, and it should not be only for the people who can afford it. It should be available to everyone, just like open source, available to everyone. People are enjoying and all those stuff. That's the type of community I want to create, and I want to like have free like couple things you will never see on my Twitch, YouTube channel, no matter how big I become, will be like you don't have to be a subscriber to look at my past broadcast, and all those videos will be available on YouTube too. Like you can see from day, like since January, I'm doing stuff YouTube as well on Twitch since last December. So those are the things I want like with the community, and I want to create like a gold standard of a community where it's like do not have to pay to be a good you to be a part of any community, and people just like open source Linux, right? Nobody has to pay, and that's how big it is. That's the type of things I want to create, and more going forward, whether with hacking, whether with AI, or just getting teaching, learning, right? You don't have to be, it doesn't have to come down to money or anything like that. And with people like you, right? Like you people like you are the reason. It's like a motivation because you guys like do Metasploit, right? You did development, you helped, taught so many, you managed people, you taught them how to create exploits, and now it's such a big thing, and everybody, so many more people have joined hands. So that's big kudos to you guys. You guys created me, and I hope I can guide other people in future and motivate at least, like do something. It's fun. It's fun. And with AI too, right? I'm just like the reason I'm doing this because I know somebody would be like, hey, I want to learn AI. Don't know where to start from. Nah, man. Like, you guys deserve it. Like, people who, like, do the open source contribution, you guys deserve the most credit in this world. Like, we give credit to these organizations about, like, oh, they, like, United Nation. Oh, they did this. Oh, they did that. Like, honestly, like open source, that's some good things to like give credits to. Like so many people, like for example, Facebook, if they never released React, so many people would have issues. So with Facebook, like they deserve credit on creating so many good technological things, right? But it's interesting. Is that's all I can say. And yeah, fun thing I realized actually I saw I was attending this tax related session with my company. They said, and I quote, you can claim tax returns, like you can claim those money which you donated to for political parties. I'm like, that is like if I like Elon Musk donating to Trump, he can like use that for tax credits. That doesn't make any sense at all because the reason he's doing it so he can get more benefits from Trump, right? So I'm like, those things are always like, oh, Trump, Elon is helping Trump or Trump is doing this and all those. But I'm like, nah, there's too much gupchup. There's too much BS. It's crazy. But yeah, hopefully, like, I just want to say thank you because you guys, especially you, right, like, gave me inspiration for open source and so many other people. And hopefully, we can create the world a better place with AI coming in. So thank you. That's all. That's all I can say. I wish we can meet in future, right? Like at DEF CON or something, and have more like chats in person too. And Discord one, I will contact you ASAP and like set up some time and we can do something fun. So thank you so much for that as well. I'm saying too many thank yous. I realize now after your message. But yeah, let's hopefully um some good chat. Like I like this, right? And yeah, let's get back into our perceptrons, the building blocks of uh, neural networks, which is also interesting. I was looking at these before the stream and I was going through during my daytime. It's amazing. These things are just crazy how things are being developed.
wx plus b, which is the summation from I equals 1 to n of wixi plus b. This node then checks if the value is 0 or bigger, and if it is, then the node returns a value of 1 for yes, and if not, then it returns a value of 0 for no. Note that we're using an implicit function here, which is called a step function. What the step function does is it returns a 1 if the input is positive or 0, and a 0 if the input is negative. So in reality, these perceptrons can be seen as a combination of nodes, where the first node calculates a linear equation on the inputs on the weights, and the second node applies the step function to the result. These can be graphed as follows. The summation sign represents the linear function in the first node, and the drawing represents the step function in the second node. In the future, we'll use different step functions, so this is why it's useful to specify it in the node. So as we've seen, there are two ways to represent perceptrons. The one in the left has the bias unit coming from an input node with a value of 1, and the one in the right has the bias inside the node.
So in the node, either there are function or there's a bias. It's always like I think the bias outside when it's coming in, that's like is what used all the time. So correction in this video at this, the title should be step function, not set function. Yeah, step function because 0 to 1, it becomes a step, right?
By the
Uh,
does is it
Yeah, it's like a step almost. So whoever is watching, excuse me. And the definition of step function should be y equals 1. If x is greater than 0, y equals 0. So there are just two values output depending on what is the value of x. So quick question. Let's see. Given score 2 times the test plus 1 times the grade minus 18, suppose W1, which is test, was weighted at 1.5 instead of 2, so this one, what the student would, uh, what the student who got 7 in the test and 6 on the grade should be accepted or rejected? Basically, then this equation we have, this our equation of, I think, 2 times test plus 1 times grade minus 18. This will become 1.5 time test plus basically 1 time grade is grade minus 18 right? So that will be 1.5 times 7. 7 plus 10.5. Base 7 plus basic half of 7. That's 3.5. So 7 plus 3.5 is 10.5 plus 6 minus 18. 16 per 5 minus 18, that's negative. So he would be rejected. See? Awesome. So hopefully that makes sense. It's interesting how simple this math is, but like the next one coming, I know is like crazy bad. Why neural networks? This is important. Neural networks basically are inspired from how our brain works. That's why it's called like to create artificial intelligence. That's how things work. So it's interesting. And one thing I want to say, these dendrites, a lot of based on what you eat, right? These dendrites release like they're not connected to each other. There's like a gap between two neurons. They release some liquid, and the people who like there is a saying, right? Like eat more almonds, your memory becomes better because these liquid that is sent to them or electricity, you get more. Like it's faster, it's better, and that's why a lot of people say, okay, there are certain nuts which you eat or certain food that helps you with this. So interesting thing. Just want to say.
So you may be wondering, why are these objects called neural networks? Well, the reason why they're called neural networks is because perceptrons kind of look like neurons in the brain. In the left, we have a perceptron with 4 inputs, the numbers 1, 0, 4, and -2. And what the perceptron does is it calculates some equations on the input and decides to return a 1 or a 0. In a similar way, neurons in the brain take inputs coming from the dendrites. These inputs are nervous impulses, so what the neuron does is it does something with the nervous impulses, and then it decides if it outputs a nervous impulse or not through the axon. The way we'll create neural networks later in this lesson is by concatenating these perceptrons, so we'll be mimicking the way the brain connects neurons by taking the output from one and turning it into the input for another one.
So basically, these axons are connected to other neurons. They're connecting. That's why there is so many neural networks. That's the same thing. Perceptrons as logic operators. Okay. In this lesson, we'll see one of the many great applications of perceptrons as logical operators. You'll have a chance to create perceptrons for most common of these and or and not operators, and then we'll see what to do about the ex- exclusive or. So not elusive, exclusive or. So X or. So exclusive or operator. Let's dive in. And perceptron. Okay.
So here's something very interesting about perceptrons, and it's that some logical operators can be represented as perceptrons. Here, for example, we have the AND operator. And how does that work? The AND operator takes two inputs and it returns an output. The inputs can be true or false, but the output is only true if both of the inputs are true. So for instance, if the inputs are true and true, then the output is true. If the inputs are true and false, then the output is false. If the inputs
Even a single one of them is false, down
are
output is
false
false,
and
right?
true, then the output is false. And finally, if the inputs are false and false, then the output is false. Now, how do we turn this into a perceptron? Well, the first step is to turn this table of true-false into a table of zeros and ones, where the 1 corresponds to true and the 0 corresponds to false. And now we draw this perceptron over here, which works just as before. It has a line defined by weights and a bias, and it has a positive area which is colored blue and a negative area which is colored red. And what this perceptron
So basically, this one going to a previous example, whether the kid who applied for the college, to our college, based on his grades and test, did he do good on grades? Did he do good on test? In yes, in both cases, then he's accepted. If it's not, it's a no in any one of the cases. If he's not accepted, he's rejected.
is going to do is it'll plot each point, and if the point falls in the positive area, then it returns a 1. And if it falls in the negative area, then it returns a 0. So let's try it. The 1, 1 gets plotted in the positive area, so the perceptron returns a 1. The 1, 0 gets plotted in the negative area, so the perceptron returns a 0. The 0, 1 gets plotted in the negative area, so the perceptron returns a 0. And finally, the 0, 0 also gets plotted in the negative area, so the perceptron returns a 0. Other logical operators can also be turned into perceptrons. For example, here is the OR operator, which returns true if any of its two inputs is true. That gets turned into this table, which gets turned into this perceptron, which is very similar as the one before.
So you see, like previously, but like the row is taken down, and OR is basically if any one of them is true, right? If the student who is applying, if he did good on any one of the things, whether both, right, test and grades, he's doing good. Awesome, accepted. He did great on test, but not so much on the uh, great on test, but not on the grades. Or he did not do good on the test, but he did great on the grades, accepted. But if the answer is no for both, then that comes.
Except the line has different weights and a different bias. What are the weights and bias for the and the OR perceptron? You'll have the chance to play with them in the quiz below.
Okay, let's see the quiz. The second and the third row, so let's see from here, right? The second and third rows of the third column from 150 onwards should be in blue in color, and they have correct value 1 for the OR operator. Okay, wait, hold up. From 150,
That gets turned into this table.
the second and third rows of the third column, yeah, onwards should be blue in color. They have the correct value of 1 for the OR operator. Yes. So this is the and here they're showing, which is interesting. When they're talking about OR, right? What are the weights and bias for the AND operator? Okay, so set the weights 1, weight 2, and the bias 2 value to values that will correctly determine the AND operation as shown above. More than one set of values will work. Okay, so we just have to find like one of the values that will work in this case. Maybe you guys can help me. So that we have a bias. What we want is basically is that we want to create an equation. This is W1 x1 plus W2 x2 minus or plus B basically. Bias is always plus because B itself can be negative or positive, but it's always added, right? Should be equal to 0, right? So let's say if this value is 1, x is 1, x2 is 1. So x is 1, x1 is 1, this is 1, let's say, and this is also 1. Or it's either 1 or 0. 1 or 0 or 0. So what we want is let's say if it is the first case, 1 1. Uh-huh. Let's say no no no. Let's say we take the second and third case where this is 1, this is 0, right? For our first case. Let's say we'll do 1 0. Then what it will become, the equation will become W1 plus because W2 will be multiplying with 0 and become 0 plus B should be less than 0. That's the equation because it is negative, it should give false. So W1 should be less than B. And with the case of 0 1, this is the first case, and there is a case of 0, comma 1. W1 multiplies by 0 becomes 0. Then W2 times 1 is W2 plus B. Again, this was not allowed. So this is less than 0. This is also gives us similar equation. less than B. And let's say weight one and two, if they both are positive, bias has to be negative. If bias is positive, these W1 and W2 should be negative. As long as anything satisfies this equation, right? Like B can be 1, W2 can be 0, B can be, let's say, -10, W2 then should be -11. And this actually becomes negative of B. So negative, negative, this will become positive. This changed basically. So W1 should be less than the negative of B. My bad. My bad. So what, and now the last one which was like 1, 1. I wish I had something better for drawing. But 1, 1. Meaver Smith, what's up, brother? How you doing? How's everything going? I know you might be shocked as well, like Bandit, like we are doing some AI related talking about bias, weights and stuff. I'm just outside actually. Oh, you are in holidays too? Yeah, I'm not in holidays actually. I had to come out to a different city for some medical and personal reason. So I just have my laptop right now and it's on Mac. So I set this up in one day and like I thought, you know what, I will do something which I wanted to do and just like stay connected with you guys, right? Like there's a lot of people there are subscribers. Um, so I just want to be respectful and still come, even though not hacking, but something, so I can talk to people if there's anything I can do for anyone, right? So, and I met Benedict. Benedict today was like amazing. So I had a chat with him. We'll be doing how to contribute to Metasploit. He was the lead exploit developer for Metasploit. So will be fun. Nice stuff coming. How about you? How's your day going? How's the week? I'm a student in this week. Oh, nice. That's awesome. That's cool. So enjoying the weekend, the holidays. Yo, if you're a student, this is great time because then Benedict, I have a bunch of questions. Let me know if you have any questions regarding how to contribute to open source, how to like get started and anything like questions like that. I would love to ask that to Benedict, right? We will have probably half an hour, 1 hour based on how busy he is. So that'll be nice. So as a student, it will be a great session for you, and you can ask questions and all those stuff. So that'll be great. Oh yeah, and we are going here to our coding W1 because the 1 1 plus B, the bias. This one is greater than or equal to 0. So we'll take our 0 1. W1 plus W2 should be equal to negative of B, basic linear equation, right? So what we know is any of these will solve. So let's say if I'm saying this is 1 plus 1 negative, and B should be a negative because negative, negative. Let's say this will solve the equation, like something like these values, 2 equals 2. So we can say for our equation here, we'll be doing. Have you done any open source work though, Almiva Smith? Resolve equation. Yeah. Oh, that's interesting. How you did that question mark, like opposite question marks. I like that. So this will be -2. This should do. Oh, my bad. 1. You should take this. This is like a free course on Udacity if you are interested in AI from Hugging Face. Don't change anything below inputs and outputs. So inputs are these, outputs are these. And what if we want like, hold up. So this will put it on the line, it will solve. But what if we want this like this? Then we want like, let's say it to be Something. Language programming. This one, I think this one is basically Python. Yeah, just some simple programming of program basic Python 101, I guess. For input, all these sets, correct output, false, 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 true, right? And the linear combination is weight 1, value 1, weight 2, value 2, plus the bias. Integer of the linear, is it, this is what I don't like about Mac. But integer value of the combination and then greater than equal. Sorry, what do you mean by language programming though? Like you mean like basically English without grammar, that type programming? And then we have correct string, yes. So this will solve our equation, right? Because greater than equal to zero, that will give us a yes, and that will do the job. So I think we are good on that side. And I can just make it a bit, no, that won't do the job. So if output is correct, yes, which was, else no. Append, print output, it prints output. If um not wrong, number nice, you got all the correct. Basically, it is checking. So test, run test. Let's see. You got three wrong. Keep trying. Wait, what up? You got three wrong. Oh, no, no, no. This is not Bash. This is Python. Bash, like if you actually want to see, if it was Bash, one of the things it would be at the end it would require fee, opposite of if, to work. And it has instead of a else, it has no, it has else, I think. Yeah, yeah. And it has then as well. No programming usually like automate, but I'm not a programmer. In a past, play with C sharp to deploy Windows. Oh, nice. Oh, okay, nice. So what are you studying as a student? Like, are you university or like are you in school, like high school? I'm just thinking. So 0, 0. Oh, I'm an idiot. -2, 1. This will do the job based on our results, right? Nice, you got all of them correct, right? Submit the answer. That's goody good. Okay, so with the OR perceptron, the OR perceptron is very similar to the AND perceptron. In the image below, the OR has the same lines as the AND one, except the line is shifted down. But you can do the weights and bias to achieve this, right? What you can do. So basically, the values will change so that the bias, right? Here, the bias was greater than W1 and W2. In this case, the bias, let's say even if it is 1, 0 or the 0, 1, whatever is the case, right? If it is either this or it is like 0, comma 1, W1 or W2, both should be greater than B or negative of B. That's all the whole thing will come down to if you take it out. Other two ways to go from AND perceptron to an OR perceptron. Increase the weight, decrease the weight. So increase the weight, that's one because weight should be bigger than the bias. Decrease the increase a single weight. No, we will have to increase both, right? 0, 1, 1, 0. Decrease the magnitude of bias. That's also one. Because bias can go smaller, weights can increase. Same thing. Not perceptron. I thought there was question two. Oh, submit. What is the next question? Maybe down here. Okay, yeah. XOR will be fun one. XOR is used. The reason why XOR is a fun and it's important to know XOR, like what is so special about it. Two things are very special about XOR. I think XOR gates are pretty cheap compared to AND and OR. And XOR is like used because it's hard to reverse engineer it. And that's why it's used for a lot of cryptographic applications. Like DES had it, I believe AES had it, the fish one, and a couple of other big ones have it. So it's good to know XOR one. After not is XOR, so let's do that quickly. This one. I like the perceptrons we looked at. The not operation only carries about one input, right? Basically, not of one. Zero becomes one, one becomes zero. The operation returns a zero if the input is one, and one if the input is zero. The other inputs of the perceptron are ignored. In this quiz, you'll set the weights W1, W2, and bias to the values that calculate the not operation. So the second input, wait, calculate the not operation on the second input and ignore the first one. So if we are ignoring the first one, we put zero, right? So it becomes zero. Bias is not needed. I will say wait for second one, just negative of whatever it is. If I send like zero, one, or not of it, one, zero, or like opposite almost. Don't change anything below. What it is doing, his linear equation is this, which should be ignored. So this is only I care about. I think in the equivalence of Canada or college diploma of networking, this year cybersecurity specialist. Oh, so you're doing diploma. I see. Oh, okay, nice. So you're doing like basically, yeah, it is like diploma. Yeah, yeah. I will give, yeah, it's basically diploma. Yeah. But it's interesting. I won't say diploma is like pre-secure, pre-university. I'll give you a big reason because once you do diplomas, right, a lot of universities more like a general knowledge of all the things. Networking, programming, cloud, AI, all these things. But after you come out of university, you had not specialized of anything. You're like a um like you know a lot of things, but you're not specialized in anything from university perspective. Diploma is to get you actually industry ready in a lot more better fashion compared to like a university degree. So don't say like my response will be don't tell anyone it's pre-university. Say diploma. That looks sexy, and you are on the right path. The reason I will say it because like I am a journal, like I did university. The reason I did like the university, not went for diploma because I loved technology. I didn't know what I wanted, right? And how things are, whatever. I was coming to Canada. I didn't know anything about Canada. Forget about the education and stuff. But good part is you're doing diploma because the way things and AI is coming, we need specialists more than the generalists, people with general knowledge. And now even for me, I'm just focusing on two things, hacking and AI. I am not focusing on anything else. Those are my two big things. And that's what, so it's good. You're doing a good job. You're on the right path, and hopefully together we can do things. And like, if you have any questions, feel free to ask me, right? You know where to reach me. Discord, right? And people who don't know, right? I have this command. You guys can reach out to me on Discord, or there's a big good community I have. We are building. So anybody have if have any questions or anything, just ask them. Cool. But yeah, kudos, mate. I'm so happy for you. And if you have any questions, feel free to ask. And you're on the right path. Don't worry. 100% you're on the right path. And yeah, like it's good. You're doing great. Do you know about the Cisco Lab like software which is like helps in creating like simulations of how routers and servers and all things work? Do you know about those? Have you worked on those yet? But yeah, let's go back to this as we are doing that. So linear equation in first course makes CCNA labs. Oh, that's awesome. Those are good. CCNA is a great certification. CCNA is like top notch certification. You get that, you're like industry ready. in a lot of ways. So that's good. Good job. I'm happy for you. You're on the right path, bro. Don't let anybody else say anything. You're on the right path. Focus and master what you are in right now. And as a student, do not forget to enjoy your student life. It's never coming back. I miss it every day, almost of my life, whether high school days or like the university days. So do not forget to enjoy it, have some fun, and make at least one or two great friends you can stay with for the rest of it. But think exists software more great to make special scenarios like GNS. What is GNS3? GNS software that empowers network professionals. Oh, this one. Yeah, yeah, yeah. This is the one I was saying. Simulator, right? Yeah, yeah, yeah. Yeah, yeah, yeah. Nice. Packet tracer. Okay, that's interesting. I think that's the one I was talking about. Yeah, Cisco Packet Tracer. This is a good one. I played with it like during university days. I saw a conference was happening outside one of the rooms in my university, and I just walked right in. I was like, yo, this is interesting. I walked right in, stayed there for an hour. Hardly like I understood like half type thing, but I was so interested. I just went home, started doing this. So I remember that. It's fun, right? And that's how you learn. So it's good. You're on the right path, and I promise, like, just keep working hard. You will be successful, right? And do not let anybody say anything else. Remember that. And if you have any questions, any doubt, let me know. Is a packet tracer, but virtual machine can deploy backups of this infrastructure and try new rules or in different scenario. PF Sense is a big one. Firewalls outside the Cisco. Yeah, yeah. Interesting thing is, yeah, like creating my PF Sense lab, there is a really good video. If you just want to try or whoever is watching, right, want to see PF Sense home lab. There is a really good video on YouTube somebody created, which was about like creating a home lab to learn networking. Network Chunk is a big guy. He's amazing. How to install? I don't remember, I guess, which one was it? Home lab. Maybe it was this guy. Maybe. Or maybe I'm wrong. I'll look at the video and I will probably post in the Discord because I remember PF Sense Home Lab was amazing video I saw and I was like, yo, this is something interesting. Build Home Lab, whatever. Maybe, yeah. But like I think with virtual machines you can create so many scenarios and do so many things. Like, there's I think uh Orion, what is that? DNS attack? Not DNS attack. DDoS attack. My passion is play with Proxmox hypervisor to try different scenario and this year learn Docker. Docker, I can actually help you with. So the Orion was one of the, I think, attacking tools long ago. I don't know even if it does exist anymore. That's what was like somebody he used using Kali and tried to attack his own home lab. So, oh really? Nice. Yo, see, community building. That's awesome. That's awesome. Proxmox hypervisor. Proxmox. A powerful open source server solution. Oh, okay. Designed for provisioning hyper-converged infrastructure, management of virtual machines and containers. Oh, okay. This is interesting. Because one thing I will tell you, if you have any questions about Yeah, it's basically like VMware XE. Oh, okay. So basically like VMware, like a enterprise version of VMware. That's amazing. And Almivar, let Smith, right? I think I call you Smith. So Smith, let me know. Text me if you want like some guidance on Docker. Docker, I love. That's what I do basically all the time. Every week I'm touching Docker. Let me tell you that. So, and Docker Hub, I think I have posted some. Did I posted my um as a university project? I did triple DES, and I don't know if I posted it here or not. I think I did. ING. Yeah, this is here. This is me. Yeah. Yeah, Kubernetes anomaly detection project. That was one of the things I did. And anomaly detection and shortest distance, not my encryption system. I never deployed that. But yeah, Kubernetes is actually interesting. And one of the things, if anybody wants to like take a very deep dive, right, into Docker and how things work, best course I have ever found on Docker is by Brian on here. Brian Holt, Docker. This guy is a genius, in my opinion. Can Docker run GPU processors on? Yes, yes, it should be. Yeah. Because like Docker is basically like going above without the need of operating system directly able to connect to the physical hardware. So you, like basically think that way, right? So it can interact getting your CPU and you can actually just like VMware. Basically what VMware in your VMware you can have GPU access, right? Same with Docker, it can do. But I will say, if you're interested in learning like me, if you're like me, right? Yeah, it's a namespace. But like, I think like thinking wise, it's like kind of like a VM because you don't need the operating system and all those stuff. It has its own C root and there is namespaces, right? And C groups. But it depends on how you give those uh, limits and what all permissions you give. It can do whatever you want. But if you are interested and you are a student, you can get like 6 months of this free through GitHub Student Project, right? I'll post this all. GitHub Student Pack, Developer Pack. Go here, create an account, and you can get like 6 months of free this thing. Go check this out. Oh, snooze. That's good. Yeah, yeah, yeah. 100% boss. 100%. It's not same, it's just thinking wise. Yeah. And here is this one. This is the course. If anyone is interested, I'll post here as well. Hey, bro, good one. Oh, Kunal, brother. How you doing? How's everything going? Sorry, because of so many things, right? Up and down things, it's hard to keep an eye on everything. But one thing I can do actually is pop these two chats out. But yeah, like if you're a student, use these. Very helpful, very, very helpful. Um, think now I can do it this way. Yeah. These resources are super helpful and it's free as a student. So go through that course, it will be amazing for you. Not this one for me. Yeah. Hopefully this helps. Yeah. And with that being said, let's get into the not preceptor, which for our EAI we need knots. So we have like 0, 0 should be false, 0, 1 false, 1, 0 false. No, no, this is the other one. And or not. Not here, right? True, false, true, false. So basically, second one is not being considered. Only, sorry, second one is the only one being considered, not the first one, and we just have negative of it, right? So if 0, 1 times 0 is true, negative 1 false, true, false. Pretty simple. And this just a job. Nice, you got all those correct. Awesome, awesome. And let's do the XOR. XOR is big one, right? It's hard to tell the in and out. Are they zeros or are they ones, or which one of them is the one and stuff. With and or, it you can tell at least one is zero, or one is one, or one is zero. With XOR, you can't tell like are both ones, are both zeros, is one or like what's going on with XOR, right? So it's an interesting one. That's all I'll say. So build an XOR multilayer perceptron. Now let's build a multilayer perceptron from AND, NOT, and OR perceptrons to create XOR logic. The neural network beyond below contains three perceptron A, B, and C. The last one AND has been given for you. The input of the neural network is from the first node. The output comes out of the last node. Okay. So basically, we have to use all these to create a. Okay. The multilinear perceptron below calculates XOR. Each perceptron is the logic. Oh, one more thing about XOR. I think you can use XOR to create any of these, or and or like basically and or and not. You can use any create any of these with XOR, if I'm not wrong. Each perceptron is a logic gate of and, or, and not. However, the perceptron ABC don't indicate the operation. The following quiz sets the correct operation for the perceptron to calculate XOR. So we have to find where and, or, and not go. Okay. So we want like let's say 1 and 1. If this is or, 1 and 1, and this is and here at the end. Okay. How we'll do it? So this is where our brain we have to use, right? At least I have to use my brain. You get to see how stupid things I do sometimes. So that'll be interesting. So this is 0, 0, and reverse engineer it. We need and XOR should come. So in case of 0, 0, it should give me 0. So even one of them being 0, either AC should produce 0 or B should produce 0. So let's say if B produces 0, it will be like a and or operator, and C and A. C should be like a not operator because it's getting only one, and this should be A should be something else, right? So let's think about that way. Ek, one, one, this. Do you have any other thing you want me to do like after AI? Because I have like 1.5 week to kill with these interesting things. This is a AND operator with our results. I wish my drawing was better. Okay, so we have, let's say, I will say this is not. For example, let's say our hypothesis, this is not, this is or, and this is and. Let's say this is called hypothesis. This is what Bayesian theorem is. Like we use, I have a hypothesis. I'll try this answer with 0, 0. If things come the way I want, great, right? Or whatever the outcome is, my results, these places will change. Let's say if I have 0 and 0, I want 0 here. right? So 0, 0, this will become 0. This will become 0. This will become 1 here. 1 and 0, 0. So this one is correct. For 0, 0, this placement is correct. Let's see now. 1, 0. 1, 0. This OR will give me 1. This will give me 0. 0, 0 and 0 becomes 0. This should be 1. So it's kind of wrong. Mm-hmm. It's basically, no, not kind of wrong. So let's go back. This is maybe then. Mm-hmm. That is interesting. So here, maybe this should be and this should be OR. So if I go 1, 0, right, it will become 1. This will become 0. This will become 1. 1 and 1, 1. In case of 0 and 1, the answer remains same, right? So we are good on that part. And with 0, 0, 0, 0, this becomes 0. This is 0. I know if one of them is 0, it's called short circuiting, so I have to don't check and it will be 0. That's also is our XOR. And let's say with 1, 1, the last one. This is 1. This will give me 1. This will go 0. 0 and 1 is 0. So I think this is our solution. Or at the bottom and not are together. Did that make sense? Hopefully that makes sense. Maybe a little bit. Or should be at B. What's going on? Okay. Okay. Like this. A. Oh no. This should be B. This should be C. Right? It's A, B, C. Yeah. Cool. And if we introduce the NAND operation, basically XOR is like exclusive OR, right? Opposite of OR, kind of. Not opposite of it. It's exclusive. It's a different thing. But same thing. There is a not AND operator as the combination of AND and NOT. Then we get the following two layers that will model XOR. So if we didn't have like AND and OR becomes no NAND, opposite of AND. So NAND and OR XOR. Interesting. And that's our first neural network, lads. Kudos. W's in the chat. Maybe like a thumbs up will be helpful. Like we created our first two-layer perceptron, basically neural network. Our first neuron. One sub clapping in the chat, man. Some fun things. How do we do this actually? Oh, oh, there's an ad break going on. Sorry, lads. I'm pausing till the ad ends. Mm-hmm. Mm. So ad breaks. Are you seeing an ad? And anybody seeing an ad? Or you guys have seen the ad? It's over. Is it good? Oh, it's more than an hour since I started streaming. Okay, community is back. Ad make is done. Awesome. So what I was saying, let's going here. So we created our first neural network, right? What this lady said, we submitted our thing. Let me go back previous here and or and stuff, right? It she talked about like this is basically A and C, like and not together becomes a NAND, right? Not and that created our first neural network, right? That together. So that's a great thing. We know now the basic, a little bit basic of how neural networks work with some gates and stuff. So that's great. Perceptron trick. What we are at? Okay, we are almost there at like our 10th. Perceptron. Okay, let's see. In the last section, you used your logic and your mathematical knowledge to create perceptrons for some of the most common logic operators. In real life, though, we can't be building these perceptrons ourselves. The idea is that we give them the result and they build themselves. And that's what like artificial neural network is, or like it's training itself, what is right and wrong. Training data, right? So using training data, we are training the algorithm. For this, there's a pretty neat trick that will help us. Okay, let's see this video.
So we had a question we were trying to answer, and the question is, how do we find this line that separates the blue points from the red points in the best possible way? Let's answer this question by first looking at a small example with 3 blue points and 3 red points, and we're going to describe an algorithm that will find the line that splits these points properly. So the computer doesn't know where to start. It might as well start at a random place by picking a random linear equation. This equation will define a line and a positive and negative area, given in blue and red respectively. What we're going to do is to look at how badly this line is doing and then move it around to try to get better and better. Now the question is, how do we find how badly this line is doing? So let's ask all the points. Here we have 4 points that are correctly classified. They are these 2 blue points in the blue area and these 2 red points in the red area. And these points are correctly classified, so they say, I'm good. And then we have these 2 points that are incorrectly classified. That's this red point in the blue area and this blue point in the red area. We want to get as much information from them, so we want them to tell us something so that we can improve this line. So what is it that they can tell us? So here we have a misclassified point, this red point in the blue area. Now think about this. If you were this point, what would you tell the line to do? Would you like it to come closer to you or farther from you? That's our quiz. Will the misclassified point want the line to come closer to it or farther from it?
Okay,
So we had a
so does the misqualified point want the line to be closer or farther? You guys know the answer? I will say like closer, right? Because the closer it is to the red area, the better. I think that's closer is the right answer, right? What do you guys think? Do you guys think closer is the right answer? See, should be, right? Okay. Great job. Indeed, the line getting closer because the red area, right? Okay, good. Let's see the next one.
Well, consider this. If you're in the wrong area, you would like the line to go over you in order to be in the right area. Thus, the point says come closer, so the line can move towards it and eventually classify it correctly.
Nice. Time for some math. Now, there's so much math involved with the AI. It's crazy. Now that we have learned that the points that are misclassified want the line to move closer to them, let's do some math. The following video shows a mathematical trick that modifies the equation of the line so that it comes closer to a particular point. want the line to move closer to them. So basically, we have this equation 3x plus 4 3x1 plus 4x2 minus 10 is this line. And let's see what this guy is saying.
Now let me show you a trick that will make a line go closer to a point.
But
Let's say we have our linear
let's say if you have this, right? What you would do, right? Do you know the answer? Like, have you thought about it? Let's do
Now
that
let me show you a
first.
trick
Wait, no, don't show anything. So we have our graph, whatever it is. This is our function 3x1 plus 4x2 minus 10 equals 0. This is the line. We want the line to be more this way because our point of interest is here in this area. So we want threshold of tolerance. You mean like the bias? I never heard of threshold. I'm sorry, like I'm very bad with terms. So, but like if you mean the 10, I think yeah, that's it. Then you're right. Like the threshold, I think it's called threshold. Yeah, I guess threshold is the right word. So because that is like what's making it go down, right? So we have to change so that 3x, sorry, we want, let's say, for example, we take a point here. X1 is, let's say, if it was whatever the value, right? 10 by 3. If this was the value, we want it to go here, which should be bigger than this. So it should be, let's say, 10 by 3 is like 3.33. I will say, let's say 5. So what we want is 3x1 plus, let's say if x2 is 0, 0 minus bias or whatever. Bias can be a negative, should be equal to 0. And let's say x is 5, so x1 should be equal to negative of bias by 3. And that's given the first equation. If I want x to be 5, 3 times 5, that should be 15. So bias should become like bigger. Bias should be like minus 15, right? That's what you mean, right?
trick that will make a line go closer to a point. Let's say we have our linear equation, for example, 3x1 plus 4x2 minus 10. And that linear equation gives us a line which is the points where the equation is 0 and two regions. The positive region drawn in blue, where 3x1 plus 4x2 minus 10 is positive, and the negative region drawn in red, where 3x1 plus 4x2 minus 10 is negative. So here we have our lonely misclassified point, the point 4, 5, which is a red point in the blue area. And the point says come closer. So how do we get that point to come closer to the line?
We
Well,
move
the
the line
idea
up.
is we're going to take the 4 and the 5 and use them to modify the equation of the line in order to get the line to move closer to the point. So here are our parameters.
So basic what they're going to do is like they want the line to pass from here, right? So they will say, okay, forget about 10. What 3 times 4 plus 4 times 5 is equal to? So 3 times 4 is 12, 5 times 4, 20, so 32. So instead of negative 10, it should be negative 32 to make it on the line. But we don't want on the line, we want it like the line to go up. So it should be, let's say, instead of 32, 32 plus more than 32.
Of the line 3, 4, and minus 10. And the coordinates of the point are 4 and 5, and let's also add a 1 here for the bias unit. So what we'll do is subtract these numbers from the parameters of the line to get 3 minus 4, 4 minus 5, and minus 10 minus 1. The new line will
Better?
have parameters minus 1, and minus 11. And this line will move drastically towards the point, possibly even going over it and placing it in the correct area. Now, since we have a lot of other points, we don't want to make any drastic moves since we may accidentally misclassify all our other points. We want the line to make a small move towards the point, and for this we need to take small steps towards the point. So here's where we introduce the learning rate. The learning rate is a small number, for example 0.1.
Okay.
And what we'll do is instead of subtracting 4, 5, and 1 from the coordinates of the line, we'll multiply these numbers by 0.1 and then subtract them from the equation of the line. This means we'll be subtracting zero point 0.4, zero point 0.5, and zero point 0.1 from the equation of the line,
Hmm.
obtaining a new equation of 2.6x1 plus 3.5x2.
But a lot of numbers on equation. I think in horizontal line exists a pipe here, middle model, or in the horizontal line. And middle part of the pipe here, middle is a horizontal line, and the middle part are in a positive area, and other middle are in the red area. Yeah, and dot are in threshold or tolerance. Okay, and if away, no closer to and not engineer. But I think no, you're right. Like you put a lot of numbers and equation to find and move. That's I think yeah, that's the right approach. 100%. This is interesting. Yeah, like you're right. 100%. Because we are moving with a lot of points, we are trying to find like how to move and stuff. So with the pipe thing or with the like putting them in the middle, part like red or negative or positive. So you're right. Yeah, nice, nice. Thank you so much for writing that though. It's a lot of writing.
Minus 10 point equation of 2 subtract them from the equation of the
But this is
line.
isn't this an interesting way like learning rate? Isn't that it's an interesting concept? Like, hey, this is where you can find and it will work, but do this learning rate. We'll learn, but at a smaller rate. We are changing our neural networks and our algorithm, but slowly.
This means we'll be subtracting zero point 0.4, zero point 0.5, and zero point 0.1 from
That's
the equation
crazy.
of the line, obtaining a new equation of 2.6x1 plus 3.5x2 minus 10.1 equals 0. This new line will actually move closer to the point. In the same way, if we have a blue point in the red area, for example, the point 1, it's a positively labeled point in the negative area. This point is also misclassified, and it says come closer. So what we do here is the same thing, except now instead of subtracting the coordinates to the parameters of the line, we add them. Again, we multiply by the learning rate in order to make small steps. So here we take the coordinates of the point 1 and put an extra 1 for the constant
When it should be like in a learning area or below the line, we subtract, but when it is above, we add.
term. And now we multiply them by the learning rate 0.1. Now we add them to the parameters of the line, and we get a new line with equation 3.1x1 plus 4.1x2 minus 9.9. And magic, this line is closer to the point. So
Hmm,
that's the trick we're going to use repeatedly for the perceptron algorithm.
that's crazy. Have you guys done ever learning rate? That's actually like the very first time I'm listening. For second example, where the line is described this 3x1 plus 4x2 minus 10, if the learning rate was set to 0.1, how many times would you have to apply the perceptron trick to move the line to a position where the blue point at 1.1 is correctly satisfied? Okay, so I think this is like where come and play. Huh. Let's see. Tell me if I'm doing wrong, right? Let's see. So this is our algorithm. Oh, I like that. And this is X1, so capital X, I guess. One second. Let me, instead of X2, I will call it Y just for this case. Hopefully that's okay. 3x plus 4y minus 10 is equal to this. What we want is that 1, 1 should be in blue area. So what it should mean that X and Y, what this blue area means, right? X comma Y with 1, 1 in this equation should lead to equation greater than 0, right? Whatever is this. So how the maths will work is what is the big difference? That's the first question. We have this equation 4, 5, 1 and
1 equals
learning rate. So we'll do is, and learning rate is 0.1. So what we'll do is 3.1, and we want it in the um, blue area, right? So +1, I guess. I'm doing right? Like I'm actually like not going to lie, I'm kind of confused. 2.9, 3.9. Yeah, yeah. Wait, no. Shouldn't it be positive? Because it's in the blue area, right? I'm thinking more like this. Uh, plus point 0.1, and then this one will be, let's say 1, because it's basically 1, right? If not given. Then this will be plus zero point 0.1 as well. This becomes 2.9. Oh, sorry, 3.1. I was saying the same thing. This becomes 4.1 and 9.9. But so two things with your one, right? With your one, the bias you have not done. And shouldn't it, like, we have to add because this is in positive, remember? So the way it moves. If it was in the negative, we want the dot to be in the negative area, then we do the subtraction. But if we want it in the positive area, we do or above the line, we do the positive. So we have to do this. Does it satisfy? 3 plus 1, 7.2, it doesn't satisfy. That's the first one. We do that. In the next game, it will be 3.2. Let's say, let me copy this. That's the first one. In the second, okay, like this. So we have the second, third, fourth. This will be 3.2. This will be 3.3, 3.4, 4.5. No, 4.4, 4.3. Because we will be keep on adding like this, right? We have to do so. That's what it asks. Like how many how many times would we apply the perceptron trick? Like how many times we add it? We want it to just work, not like make it so go bombastic. Bomba fantastic. Mr. Bombastic, Bomba fantastic. So this will be like 9. Okay. So 7.8, still less. So we keep going. And the fifth one, sixth one, 3.5, I'm actually like I'm doing it because my brain is going to make mistakes if I don't do it properly. Either it will make mistakes. 8. So I think so 4.5. This will become 9. No, this will not become 9. This will become 8. This will become 1.6. So 8.6. We want one more after this. 8.6. It's always a 2 jump, and this is reduced by 1. So 8.8 and then 9, and this will be 9. So I think we have 7, 8, and I think ninth and 10th. So we need like 10, if I'm not wrong, to make this work. We need to make it like equal, right? That will do the job. If not equal, like at least then we need the 11th one. So with 2, this becomes 4. Wait, yeah, this becomes 5. 9.2, 9.1. So this will work. This equation will work. 10th one. Does that make sense? Like what we are doing? 10. The reason we need 10th because it's equal to 0, right? Okay, 10th. So, Almir Smith, does that make sense? Like, did I explain it correctly? Why, what we are doing? So, and we just can go here quickly. I'll show you.
Obtaining a new equation 1 equals 0. This new line will actually move closer to the point.
See the
In the same way, if we have a blue point in the red area, for example, the point 1, 1, it's a positively labeled point in the negative area.
positively labeled point in the negative area.
This point is also misclassified, and it says come closer. So what we do here is the same thing, except now instead of subtracting the coordinates to the parameters of the line, we add them. Again, we multiply by the learning rate in order to make small steps. So here we take the coordinates of the point 1, 1 and put an extra 1 for the constant term. And now we multiply them by the learning rate 0.1. Now we add them to the parameters of the line, and we get a new line with equation.
Does that make sense? What is going on? Hopefully it did, right? If it not, let me know. Like, if it does, give me a thumbs up. That'll be helpful. If not, let me know. I will explain again what they are doing. But like the whole idea is, let's say if you have a line here, this is our graph, this is our line. If a point that is misclassified is here, we want the line to move up so that it becomes below the line. The red comes below. But if a line is here, the dot is here, we want the line to go down so the point is in the positive area. And that's the whole idea. And if you do, like, if you add those numbers, right, that's how it makes sense. Because the line is not technically going up, it's the point technically with the more weight, it comes in this area. When we are reducing the weight, this like point gets rejected or comes in the red area. Weight defines whether it's in the red area or the blue area, right? Okay, perceptron algorithm, our last probably topic because it's getting 1 a.m. in the time zone I live in. And no ads are coming, so that's good. I don't want any ads for you guys. At least right now, at least for some time, right? No. Okay, so let's get here. Perceptron algorithm. And now, with the perceptron trick in our hands, we can fully deploy the perceptron algorithm. The following video will show you the pseudocode, and in the quiz below, you will have the chance to code it in Python. Angle of the green line are same. No, no, no. Angles, like what do you mean by the angles of the green line? Only move coordinates like so no, actually the whole thing is, right? Points are not moving. Points are not moving. Let me show you example. Our example was that we want 1 comma 1 is a blue point, right? In our example, previous example, blue 1 comma 1 is a blue point. Mm, in this, right? 1 comma 1 is a blue point. Thing is, we want the blue point to come in the blue area. It was in the red area here, like this. Point is, let's say if this is 1 and this is 1, our point is here. And let me do the blue point. You can't move the point anywhere. If you think about it, we can't move the point. Whereas point, we know it is at 1, 1. We are not moving the point. What we are doing is right now, our algorithm says that, okay, this is the line. What we are doing is moving the line a bit down, or if you think about it, we are making the line come a bit down so that this blue area, right now, this is the blue area, this is the red area, right? We are making the line come down so that it looks more like this. The line somehow, right? If this is again 1, 1, or let me make it like, let's say if this is 1, 1, this is our blue point. What our goal is, we need to change the algorithm so something like this happens, and this blue area comes here, the dot comes in the blue area, and this is the red area. You see how we move the line? So that's what we are trying to do because we want like the blue dots to come in the blue area, the red dot to come in the red area. How the area is defined? Based on the line. And we can change the line. And how we change the line? Because there is an equation of a line. Line has an equation, right? Line has an equation. How we can change the equation? We are not changing the points, we are changing the constants around the line. So 3x, 4y, it can be 30x, 40y, negative 40y, right? But the intersection to move the line is validated. But in the there will be. I understand. So because the intention to move the line is validate data, doesn't. Yeah, yeah, yeah. Yeah, that's the line. That's the whole idea of the intention of the line is so that we can define whatever we data we have, we can validate if it is a positive and if it is should be in the blue area or red area. And there are no false positive. Yes. You're right. Yeah. So and that's the whole intention of the line, and that's what we are trying to achieve. And the thing is like um the more data points you have, right? It's like it's a natural life. In real life, right? Data is there will be like 95% correct data. There will be still 95 still is a big number, so it's big. I will say 99% data is right. There will be still some false positives, and there will be some wrong data, and that's what we are trying to reduce that with these. That's the intention of this, right? Hopefully that makes sense. Like that's the intention of moving the line. So less errors are made. So if we put a point in our um, software, it tells us whether the person is rejected or should it be in blue area or red area. Hopefully that makes sense, right? You got that? And there are no ads coming, right? But I love the question. The question actually clarifies all the things we are learning. So yeah, I got 30 views. I never had that. But currently there are no viewers. But thank you. That's actually a good question. I love that question. And you're like the statement I will rather say. And let's complete this. I think this will be the end of the day and with some Python code. And now with perceptron trick in our hands, we can fully develop the perceptron algorithm, right, with the Python code at the end. Let's see.
Now we finally have all the tools for describing the perceptron algorithm. We start with a random equation which will determine some line and two regions, the positive and the negative region. Now we'll move this line around to get a better and better fit. So we ask all the points how they're doing. The 4 correctly classified points say I'm good, and the 2 incorrectly classified points say come closer. So let's listen to the point in the right and apply the trick to make the line closer to this point. So here it is. Now this point is good. Now let's listen to the point in the left. The point says come closer. We apply the trick and now the line goes closer to it. And it actually goes over it, classifying it correctly. Now every point is correctly classified and happy. So let's actually write the pseudocode for this perceptron algorithm. We start with random weights w1 up to wn and b. This gives us the equation wx plus b, the line, and the positive and negative areas. Now for every misclassified point with coordinates x1 up to xn, we do the following. If the prediction was 0, which means the point is a positive point in the negative area, then we'll update the weights as follows. For I equals 1 to n, we change wi to wi plus alpha times xi, where alpha is the learning rate. In this case, we're using 0.1. Sometimes we'll use 0.01, etc. It depends. Then we also change the bias unit to b plus alpha. That moves the line closer to the misclassified point. Now if the prediction was 1, which means a point is a negative point in the positive area, then we'll update the weights in a similar way, except we subtract instead of adding.
So prediction was 0 means like it was a blue point, but it was given a false or like a negative area. Prediction was 1, right? Like, oh, it came in the blue area, but it actually was wrong. It should be in the red area.
This means for I equals 1, change wi to wi minus alpha xi, and change.
I think you have time how Shazam audio recognition works and exists. When you have time, how Shazam works and exists. Caller. Oh, okay. Do you have like a video or like a link for that? I would love to look. That's actually a really cool thing. I would love to look into that. Can you, or maybe let's look at the link after we complete
Change
this
the
chapter.
bias
Let's
unit
look at it.
b by adding. This means
That's nice.
for I equals 1, change wi to wi minus alpha xi, and change the bias unit b to b minus alpha. And now the line moves closer to our misclassified point. And now we just repeat this step until we get no errors, or until we have a number of errors that is small. Or simply we can just say, do this step 1,000 times and stop. We'll see what are our options later in the class.
Let me just point it. So let me pin this. So I'll remember. I need to pin this so I remember. But okay, so we have this, right? I think this should be done fast. There's a small error in the line in the above video with in that WI should be updated WI plus alpha XI plus or minus depending on the situation. Coding the perceptron algorithm. This is how there's so many statistics software which are based on R actually. Some of them, majority of them are based on R. They look like exactly like this. I'm getting PTSD tonight with my stats class from university. Pray for me. Okay, jokes aside, coding the perceptron algorithm, time to code. In this course, I will not be coding it today. I'll let you guys code it. I'll have the code ready for tomorrow just so you guys can see. And I will post in the Discord, right? You can go to the Discord with the command. In this quiz, you will have the chance to implement the perceptron algorithm to separate the following data given in the file data.csv. Okay. Uh, and you guys can go to this, right? I'll send the link. So if you want the data, I don't know if you guys can access this. Let me know. If not, I will like send you the link to how to get set up account, whatever. So going back, recall that perceptron step works as follow. For a point with coordinates P and Q, label Y and prediction given as Y hat step. Step basically is 0 or 1. Y1 x1, y2 x2 plus B. For coordinates, x1 will become P, x2 will become Q. Label is this. If the point is correctly classified, do nothing. If the point is classified as positive but is given a negative label, so answer came as 0 even though it should be as 1, subtract. Oh, sorry. If the answer came as 1, yeah, if the answer came as 1, there are 1 and 0, right? So if answer came as 1 but it should be 0, subtract, moving the line down. If the answer came as negative, basically 0, but it should be positive, add that. Then click test run on the graph of this, to graph the solution that Perceptor algorithm gives you. It will actually draw a set of dotted lines that shows how the algorithm approaches the best solution given by the black solid line. Feel free to play with the parameters of the algorithm, number of epochs, learning rate, and then randomizing of the initial parameters to see how your initial coordinate condition can affect the solution. Okay, so data.csv is here. That's a lot of data. I don't think I can add that in the chat, but we are using NumPy, a Python algorithm, and here is the code. Okay, so our code will go here. Basically, we have to type this. So actually, this is on you guys. I will be doing it tomorrow. Today is like 1:30 for me. And if you guys, I'm too sleepy, honestly. So if you guys want, just code it right now. I will check it. If you want, I can check your code. I check so many people's code, so like at my work. So I would love to check your code if there is anything I can do. Um, yeah, I think that's all for today. And let's look at the thing you mentioned. And so, oh, I got some hundreds. Oh, thank you so much. Thank you, thank you. This was amazing. Thank you. What was it? How Shazam records and exists called Jimmy Alf. Wait, hold up. I have the name here, right? Yes,
Plan, design, and scale
for 10 minutes. Okay. This part, like, or 10-minute part, is it?
frecuencias que en el segundo punto, cuando
Oh, this is, I don't understand. One second. Oh, this is all in Spanish. Hold up. I don't understand Spanish. Mm, what can I? Oh, that's why you were able to type like the question mark, the The question mark here. I tried the translation is not available on subtitle, I believe. Here if you go, auto translate maybe. Oh, there is auto translate. Nice. Okay, nice. Let's see.
Cuando la canción de la base de datos con la que estás comparando es justo la que has grabado tú con tu móvil. Veis que en el
Comparing is exactly the one that you recorded with your phone.
segundo 43 de la canción se usaron las mismas frecuencias que en el segundo
43rd second of the song, the same frequencies are used as in the fourth. Okay.
4 de la grabación del móvil. Pero es que un segundo después volvieron a coincidir. Y otro segundo después volvieron a coincidir. Y así hasta el final. Hubo durante 20 segundos muchas coincidencias.
Right. This guy is too fast. 1 second. Did I accidentally? Let me reduce the speed. It's too fast.
Y eso significa que es un match. El algoritmo ha detectado qué canción estaba sonando. Si estás en Shazam te dirá, aquí puedes comprarla en iTunes, y si estás en YouTube te dirá bloqueado en 170 países, desmonetizado y buenas noches. Situaciones distintas, pero el reconocimiento es el mismo. Y aquí es donde podemos empezar a atar cabos, porque hay mucha gente que sube las canciones aceleradas o deceleradas a YouTube o a Facebook para que no les detecten estos algoritmos. ¿Por qué ocurre esto? Pues volvieron de la base de datos de Shazam, se usaron las mismas frecuencias que en el segundo 2 de la canción que has grabado tú con tu móvil. Y en el segundo 30 se usaron las mismas frecuencias que en el segundo 4. Y cada circulito es una de esas coincidencias. Pero son coincidencias distribuidas aleatoriamente. En cambio, mirad qué ocurre, cómo se manifiesta el resultado del algoritmo cuando la canción de la base de datos con la que estás comparando es justo la que has grabado tú con tu móvil. Veis que en el segundo 43 de la canción se usaron las mismas frecuencias que en el segundo 4 de la grabación del móvil. Pero es que un segundo después volvieron a coincidir. Y otro segundo después volvieron a coincidir. Y así hasta el final. Hubo durante 20 segundos
Oh,
muchas coincidencias. Y eso significa que es un match.
oh, so it like creates like this whole matching the dots, and it like, okay, this tune matches this songs, this, and like it keeps matching. Oh wow, this is amazing. I'll post in the. That's amazing. Oh, thank you so much. Thank you so much, man. This is actually pretty good. Post here too. That's actually interesting. So they are using the same um stats, right, behind the game. This is like amazing. Have you seen this? Objective. Respose love. Obstacle. Your beautiful face. Baby. I love YouTube, man. I love online community, the things they do. But that's amazing. Like, so is there like this will be interesting. This is what you guys can see my whole things look like. But that's amazing how Shazam does. That's beautiful. Like we can like work towards something interesting like that. Like just show something quick. Let's see if AI can help us create once we learn AI. Cool. Thank you so much, man. Thank you so much. This was a great learning, actually, how things work. So, everyone, please say thanks to my boy, Almivar Smith, and please give him a follow. I haven't followed him, so now I'm following you. Thank you. Thank you so much, Almivar, my man, Mr. Smith. But yeah, for everyone else, thank you so much for joining again. I know, just wait for one more week. After 26th, I'll be back in my old game with all the things working properly. But till then, thank you so much for joining. Hope you have a great day. Hope you have a great weekend, long weekend coming. Happy Good Friday to everyone. Happy Easter. Hope you get time to spend with your family. Love you, stay safe, and like always, bye.